students, and welcome back to Study Room. So today we're going to start a new topic called the sources of energy. So why is this chapter important and why are we studying chapter on sources of energy, you might think, right? Well, it is important because the world that you all are going into is a world that is going to have a lot of energy crisis, and the whole world is going to be looking for a lot of new energy sources that can be used, which do not pollute our environment and which do not leave a very bad environment or a very bad state of the earth for the next generation. So that is why it is important for us to find new sources of energy. So a lot of you would probably find yourself in this field, involved in finding and researching about the new upcoming sources of energy and how it is better for our world and what we can do to improve the situation of our earth and everything related to that. So that is why it is very important for you to study this chapter, because this might as well be what you are doing in the future. And even if this is not related to what you're doing in the future, it is very much related to your earth and the place you are living in. So that is why it is actually very important. Okay, let's go. So first of all, we're going to see a did you know video, which is going to give you a lot of facts about different energy sources and how much of a country's or a place's consumption that they can satisfy. So this should give you an idea about how different sources of energy can be utilized and how much of a population a specific source of energy can satisfy or provide for in a specified amount of time, and why there is a need for change. Okay, let's watch the video. So here it's asking you, did you know? It's asking you a lot of did you know questions. Okay. So the first is that 1 hour of sunlight could actually meet the world's energy demand for a whole year. Just 1 hour of sunlight. Can you compare the two quantities, 1 hour of sunlight and a whole year of the world's energy demand? How much is that? That is a huge amount, right? So these facts should start racking your brain, and you should start using your brain to think actually how much energy we use and how much energy can be supplied using these other sources, these sustainable sources. Then it says that natural gas reserves could supply current world demands for more than 280 years. And even bigger time than 1 year. It's 280 years, and natural gas could supply the current world demand for more than 280 years. Then it says that wind power could supply 40 times the current worldwide electricity consumption. 40 times the current electricity consumption of the whole world. Then it says that in the United States, geothermal energy reserves could equal 2000 times the annual energy consumption. What does that mean? That geothermal energy only, like alone itself, can equal 2000 times the amount of energy that the United States consumes. Okay. Now, the next fact says that biofuels could one day replace 30% or more of the current US oil consumption. And it says that the waves and the tidal streams could provide 20% of the developed nation's electricity needs. So now, if you can see all of these sources, be it sunlight or be it waves and tidal streams, all of these sources are the non-polluting sources, right? So these are the sources which are going to satisfy our needs almost as equal to or even more than the sources which were satisfying our needs but polluting the environment too. So the aim is to still satisfy the needs of the people but not damage our environment as much or bring as less damage to our environment and earth as possible. Okay. The next point says that coal, the largest source of electric power, can be mined in more than a third of the countries in the world. That coal, the largest source of electric power, can be mined in more than a third of the countries of the world. And that is why it is so widely used, because it is so cheap and so easily available also. Okay. Then it says that a single barrel of oil has as much energy as there is in the food to feed an adult for 2 years. Just think about it. How much energy do you use in a day? It takes a lot of energy to work through the day, right? Now think about how much energy would you be consuming in 2 years. The food that you eat for 2 years, the energy that that food produces, a single barrel of oil can produce. So this is just, all of these facts are just trying to, make you think about how much energy we use and how much energy can be replaced by which energy, and which energy is better for our environment. Now, how do we harness energy sources in a clean, safe, and a sustainable way? That is the question of the day. And what role can each and every one of us play as energy concerned citizens? Right? To find out, you can learn more, help more, and save more. Right? So, what does this mean? You can learn more, help more, and save more. You can learn more about what are the damages that the current types of sources of energy are bringing to our world. Help more, help to find out new sources which are less damaging to our environment and our earth, and save more, that even if you can't do anything else, at least save the energy that you can. Don't waste energy, don't take energy for granted. Okay, let's move on. Okay, let's move. Now, the next slide says examples of energy conversion. What does conversion mean? Conversion basically means going from one state or one form to another. So, energy, one thing that you should know, that you will study more about, is energy conservation. So, basically, energy is conserved, which means that it doesn't get destroyed or it can't be created per se. So all that happens is that it changes from one form to another. Like you said, like we used in the last chapter, or in the chapter where we did the last chapter that we did about circuits, we used the energy and work concept there also, right? We said that energy and work are actually equivalent. The energy that is stored is what is used to do any action or work. So can you see there are two different forms of energy? The stored energy is the one that is like stagnant, it's in one place. But the work is actually when the energy is being put to some use. So like that, energy can only be changed from one form to another. So here is an example. This example says that if you drop a plate from a height, don't drop a glass plate or you'll get scolded at home. Drop a plate from a height, say you drop a metal plate from a height, the potential energy. Now, what is the potential energy? The potential energy, which is written here, is actually just the energy which is due to or by virtue of. By virtue of basically means that the reason, like that is the reason behind it. So by virtue of position or height. So potential energy is basically the energy when an object is stationary, say it is held at a particular height from the ground. That energy that it has when it's in one place, say at a particular height from the ground, but it's in a place, it's stationary, it's not moving. That energy that is by virtue of the position of the object or the height of the object is the potential energy. Okay. So this potential energy, which is the stored energy here potential energy is the stored energy, and the potential energy of the plate is converted mostly to sound energy. So when the metal plate, make sure you use a metal plate, hits the ground, it makes a lot of sound. So here, so in everything you do in life, in everyday life, you can actually relate it to energy conservation or conversion of energy from one form to another. So here the energy that was stored in the plate for being at a particular height was converted to sound energy when it hit the ground, right? So similarly, you can use this in a lot of other concepts, like simple as we have always discussed. If you're sitting in one place, you are like trying to get as much energy as you can, and then you just quickly do one lap of the school ground. So that stored energy was used up to do that work or the action of running around the ground. So energy just goes from one form to another. Okay. Okay, let's move on. So another example of energy conversion is lighting a candle. So what is being converted here? That the chemical energy in the wax is being converted to heat and light energy. So what the chemical energy means is the burning of a wax. The burning of wax is a chemical reaction. So there is some chemical energy generated which carries forth the chemical reaction. Obviously, energy is required for every reaction to take place, be it chemical or physical. So that chemical energy is used up in way of heat and light. Okay, so if you can relate this to the chapter that we did just now, the chapter on circuits just 2 chapters ago, in that we said that the energy of the battery that it is taking up or it is expending for maintaining the potential difference across the circuit is given out in the form of heat in a purely resistive circuit, or if there is a appliance like a fan which can move, it is used up to move that fan. So there also the same thing is happening, that the energy of the battery is being used up in some other form in the circuit. So in any example in life, you can apply this energy conversion or energy conservation. Okay. Now, why is there an energy crisis? So, your PPT says that energy in the usable form is dissipated to the surrounding in less usable forms. So, any source of energy we use is consumed and cannot be used again. So, what does this mean? This means that energy in a usable form, which means energy that can be useful for us, once it's consumed, it is given out into the surroundings in less usable forms. What does that mean? The say electrical energy, right? So your electrical energy was used to run your heater. The heater provided you heat. Yes, it is working till there. But that heat that is being given out into the environment, that is also energy. That is heat energy. But is that heat energy being used in any other thing? No, it is not being used. So basically, that heat energy or all of that electrical energy that was used to generate this heat energy is just lost to the environment, right? So that is why we have an energy crisis, because all of the usable forms of energy, once they are used, they are dissipated or they are disappeared or they are sent out into the surroundings or the environment or the universe in a much less usable form. So that is why it is very important for us to have a lot of energy, and that is why there is an energy crisis, because all of the useful energy is being thrown out, it's just being wasted. So that is why we need more sources of energy, and that is why there is a shortage of energy, because all of this energy is being wasted like this. So we need people who can think of other creative ways in which, say, that heat energy that is being given out by the heater is not wasted. Say it is collected in some way and it is used to perform some other activity, and from that activity the energy that is sent out is again collected and used for another activity. So like that, we need some people to come up with any kind of creative way to reuse that energy or create more sources of energy. Okay, so any source of energy we consume is wasted, not wasted, it is consumed and it cannot be used again, or it is sent out in a form which is unusable for us. Okay, so it says that different sources of energy in our life. What are these sources? This is the petrol that you fill into the car. This is, what is this? Mining, right? They are digging out something. They are digging out, let's say, they might be digging out coal from the ground, which will further be used to generate energy. This, your oven, your washing machine, your refrigerator, all of these are sources of energy. Fire is a good source of heat energy which we use in our everyday life. This are examples of electrical energy, right? Okay, great. Let's move on. Now, it says factors which determine a good source of energy. So, these are the factors that will determine if a source of energy is good or not. So, what does it say? It says, while selecting a fuel, one should question about how much heat does it release on burning. Does it produce a lot of smoke? Is it easily available? And would the fuel selected also depend on the work to be done? So, all of these questions are very important questions that you would always think about when you're choosing a source of energy. How much heat does it release on burning? So, say if you're doing a cooking, your main aim is to cook. So, would you need very high heat or would you need very less heat? You would need a lot of heat, right? If you want to cook something, you need high heat. So in that case, you will consider a source which can provide you a lot of heat. But at the same time, you look at the next question. Does it produce a lot of smoke? If it produces a lot of smoke, would it be easy for you to cook with it? It won't be, right? You will be coughing half of the time and you won't get any work done. So then you would have to choose a source that does not produce a lot of smoke. Then, is it easily available? If you want to cook in your homes, would you like to choose the fuel which is not at all available and you have to travel hours and hours to get it, or something that is readily available to you? Obviously, that something is readily available to you, right? Then, would the fuel selected also depend on the work to be done? Is the fuel going to be used only for this particular purpose, or can you use it for some other purpose when you need it too? Or can it be used only for cooking? So that you would think that, okay, one fuel can probably satisfy a lot of my needs. That is more useful to me, right? Other than going to buy a different fuel for cooking, a different fuel for something else, some other purpose, right? So all of these things are the questions that you actually ask yourself. Now, a good source of energy. So these are some things that a good source of energy is actually supposed to have. That it would do large amounts of work per unit volume or mass. So these are things that you just have to remember. Okay, there is not much to think about in this, but these are logical points, so I don't think it would be very hard to remember. So it says it would do a large amount of work per unit volume or mass. What does that mean? That in a small amount it is able to do, that fuel is able to do a lot of work. So fuel is a word that we are referring to. Fuel, we just don't mean petrol. If you're thinking like fuel means petrol, no. Fuel, we just mean anything that fuels the work that we have to do, or any source of energy. Okay, so it says that one that would do a lot of work per unit mass. That means if we have to do a lot of work, we don't have to get like a lot of that source of energy. Even a small amount of that energy can actually help us do a lot of work. So that is what it means. The second point says be easily accessible. That's a pretty obvious and logical point, that you would not want to have a source of energy that you have to travel or go somewhere very far to get. No, that is not ideal. You want something that is readily available to you, that is available near you also, right? Which is easy to store and transport. See, suppose you have to take it from one place to the other. It is going to take some time till you get to that place. If your fuel goes bad in that time, then it's useless for you, right? So you look at a fuel that is easy to store and easy to transport. Then most importantly, it must be economical. This is the most important point, that it must not be super expensive, right? Otherwise, it does not qualify as a good fuel. If you have to spend a lot on it, then it's not a fuel, because it would cost you a lot of money to do just daily everyday activities like cooking, right? So economical, it being economical is one of the most important factors. Okay, now what is a good source of energy? We just studied about it. We studied that more work per unit volume or mass. Just write a proper statement that a good source of energy is a source of energy which qualifies or which fulfills all of these following points. Okay, so you write more work per unit volume mass. So you can just write one sentence here like that, so that it explains what you are actually writing the points about. Don't just go writing point 1, point 2, point 3. That's not the way you write it. Okay, then what would the next thing be? The next thing that would be that it is easily accessible, right? It should be available near to you, or you can also write readily available. Readily available means that it is easily available. Then easy, I'm just writing it in short form. You would write the whole sentence, that the fuel is easily accessible or readily available. The fuel is easy to store and easy to transport. You write the whole sentence. Okay, easy to store and transport, not or. Easy to store and transport. Then what would it be? That most importantly, it is economical. So any fuel that satisfies all of these points, or at least some of the most important points, is called a good fuel. Mostly we look at a fuel that qualifies all of these points or satisfies all of these points. Okay, great. Next question says, what is a good fuel? Oh shit. So the points for this question would be similar to the ones in the last question, where we say that it should provide, more energy or more work for less amount of unit or mass. It should provide less, like we said, what are the things that you would consider when you are, thinking about a fuel. You will say that, does it provide a lot of smoke? So it should not provide a lot of smoke. Then you should say, does it provide a lot of heat? Then it should provide a lot of heat, so that more work can be done using that heat. So all of those points that we saw, you are going to write them. So another point was that, is it easily available? And then, can it be used to do any other type of work too? Okay. So all of those points that we considered, you would just write it in your own words. So I'm not writing it all down because I've told you the points from the previous question. So it's a lot similar, and you go back to the slide where we discussed the points about a good fuel, the smoke and the heat and everything like that, and you make that into the points here. Okay. So if I want to give you a brief here, you'll write about the heat factor, how much heat does it produce? Smoke factor, does it produce a lot of smoke? Then obviously availability, and can it be used to do other work? Okay, great. Moving on. So the next question says that, if you could use any source of energy for heating your food, which one would you choose and why? Which one do you think should be your source of energy for heating food? So actually, if you have studied about this, or you might, we will when you go forward, the best fuel for cooking is known to be natural gas. And why? I'm just writing here in short, in arrow form, but you will write it in a proper point form. Why? Because it is a clean fuel. It provides high heat. It does not provide a lot of smoke, almost no smoke. It is easy to transport. And it is economical. So, can you see there are some overlapping points between the good fuel and good source of energy. So, you take all of them into account and write your complete answer. Okay, so natural gas ticks all of these boxes for us. So, that is why we consider it a good fuel for cooking.